Smiling. Okay, good morning, dear viewers, the wonderful pupils that you're having this morning. Today we are going to have some mathematics, primary 6 children. Let me hope you are there and ready to learn. Our topic is number patterns and sequences. However, before we happen to get to that, remember we are in this period of COVID-19. And I'm reminding you that we are expected to follow the SOPs. Wash hands regularly from running water. Wear your mask. And you have to put it on well. You cover the nose, the mouth. Social distancing. And you stay home and keep safe. Now, back to our point. Under number patterns and sequences, you are going to have a lot of content that you are going to be looking at. And basically, what I want us to look at today are what we are going to refer to as factors. What is a factor? A factor is that number that divides another exactly. And in this case, I can give an example. For instance, if I happen to be having a 4, which are the numbers that can divide my 4? The first one that I have to think of is a 1. Then a 2 comes in, and thereafter I can have the 4 itself. Boys and girls, these numbers that, like I've said, that it is a number that can divide another exactly. Multiplication and division co-work. They work together. So there is no way you can think of dividing and you leave multiplication apart. So when it comes to that, we are going to be using our multiplication to identify which factors we are going to have for a particular number. And on top of that, before we happen to go in details of what we are having here, there are certain ideas that we need to have at the back of our mind. And to begin with, we have those numbers that have only 2 factors. There are numbers that have only 2 factors. That is the number itself and 1. And these ones are referred to as prime numbers. Prime numbers, and like I've said, prime numbers, numbers that have only 2 factors, 1 and the number itself. Prime numbers are numbers that have only 2 factors, 1 and the number itself. And an example of this is, e.g., I'm giving examples of the prime numbers. We have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, and so on. There are a number of them, but I've just given an example of the prime numbers. those that are having only two factors, 1 and the number itself. Then we have another category. If we have those that are having only two factors, then we also do have those that are having more than two factors. And these ones are referred to as composite numbers. Composite numbers, numbers that have more than two composite numbers are numbers that have more than two factors. And an example, we have 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, 21, 22, 24, 25, 26, 27, 28, 30, and so on. Those such numbers have more than two factors. My dear boys and girls, the reason as to why I'm looking at this is because we are going to talk about factors, and we need to know the different types of numbers when they are categorized using the idea of factors. Now, having seen these two types, then we also have another thing that I want us to put at the back of our mind. Note. One is a factor of all numbers. So you can never think of getting the factors of a number and leave out the 1. And again, a number is a factor of itself. A number is a factor of it. So then, checking our factors of the different numbers, there is also a basic that I want us to look at. We have numbers that are exactly divisible by 2. These ones you can tell just from the look of the number that has been given to you. Any number that ends with the digit 0, 2, 4, 6, 8 is an even number and it has 2 as its factor. Then another one is the one that must always be having a 3 as its factor. That is a number whose sum of the digits in that particular number will be giving a multiple of 3. A multiple of 3, that is the number that can divide a 3. Alright, now into our lesson for today, we are looking at the factors of numbers. Listing factors of numbers, and when I say list all the factors of 8. How am I going to get it? What am I going to do? Here I'm going to ask myself, what are those numbers? What is a pair of numbers that when I get to multiply, I'll get the result as 8. And like I've said, 1 is a factor of all numbers. So in that case, I'll say 1 times 8. That is a pair. When I multiply 1 by 8, I'm going to get 8. And in the simple term, when I also get 8 divided by 8 is 1. It doesn't give a remainder. So 8 can divide 8. And so it's 1. 8 divided by 1 is 8. And that means the 2 are factors of 8. Then you can think of another one. Like I have a 2. Why a 2? Because I said 2 is a factor of all numbers that end with 0, 2, 4, 6, or 8. And in this case, 8 is among them. So we have 2. What should I multiply by 2 to get 8? And I'll say that is a 4. 2 times 4 is 8. And that means I have my 2 factors at hand. Factors of 8. Why am I using curly brackets? Much as it's not a set, but I want to have them all together. And that's where I'll say I'm identifying them from my working here. The reason for my having the arrows is to show how I'm going to be listing my factors. 1 is a factor, 2 is a factor, and I'm going through an order. I don't have to produce it in a jumbled way. No, I have to give it in an orderly way. 1, 2, 4, 8, and I'm closing. Those are the only numbers that can divide 8 exactly. Then, like we always have our needs, I'll double underline. In mathematics, neatness has to always be observed. Then my second number can be list all the factors of 24. So in this case, I'm going to identify which numbers can divide 24 exactly. And the first one I'm gonna begin with is a 1. Why 1? 1 is a factor of all counting numbers. And here I say, what number do I multiply by 1 to get 24? It is the number itself. When I multiply a number by 1, I get that particular number. So it's not changing anything. Then looking at 24, can I have 2 as a factor? And it is a yes. Why? The last digit, which happens to be a 4, is what among the digits that I gave. Those that can be exactly divided by 2. So 2. What number do I multiply by 2 to get 24? And that is 12. So 2 is a factor of 24, and so is 12. Then I also said that for a number to be exactly divisible by 3, the sum of the digits, my digits in 24 are 2 and 4. So what is their sum? Their sum is 6. And when I look at table 3, 6 is among the multiples of 3. And that is 3 also is qualified. What do I multiply by 3 to get 24? That is my 8. And I'm continuing. This is not all. I've not yet exhausted them all. Then I look at the next one, which happens to be a 4. Can I divide 24 by 4 and just come up with a remainder? And it is a yes. Then, what number am I multiplying by 4 to get 24? That one is a 6. When I continue 5 is a no for me. Why? A number to be exactly divisible by 5, it must end with a 5 or 0. So it's a no. 6 is already here. 7 is a no. 8 is already here. 12 and 24. So I'm getting my factors from up going downwards. We follow an order. Then down going up. Factors of 24. Which ones are these? We have 1, 2, 3, 4, 6, 8, 12, and 24. So those are our factors of 24. Any number outside this will give a remainder when you divide it by 24. Those are the only ones that can divide 24 without a remainder. And like I said, we double underline our answers for neatness. List down all the factors of 35. I go 1 times 35. By this time round, you know the reason as to why I have to begin with the 1. Like I said, 1 is a factor of all numbers. Then I get to 2. May I use the 2? And that will be a no. Why? For a number to be exactly divisible by 2, it must end with 0, 2, 4, 6, or 8. And that one is ending with a 5. So it's a no-go for me. And then I have 3. What is the sum of 3 and 5? That is 8. And 8 is not a multiple of 3. Then I look out for which one I can use. And that one is a 5 for me. Why? It is ending with a 5. 5 times 7. And these are the factors of 35. I'm getting them up, going down, down, going up. We have 1, 5, 7, 35. I'm underlining. And my last example here is, what are the factors of 17? I want to get them. And I will begin and say 1 and 17. These are automatic. Why? A number is a factor of itself and 1 is also a factor of each and every number. So, looking at my 17, which other number can divide it exactly? And flashing back at our different divisibility tests, you realize 17 hasn't got any other number. And that means the factors of 17 1 and 17 is, so you also double underline. So, having looked at our factors of numbers, we have got the 4 different examples. Factors of 8, We got them. Factors of 24, they are there. Factors of 35, we have them here. And the factors of 17. Now, what type of number, according to the factors it has, is 8. And you realize 8 has more than 2 factors. So that means it is a composite number. A composite number is that number that has more than 2 factors. So 8 is qualifying to be a composite number because it has more than 2 factors. Then we have 24. It is having 1, 2, 3, 4, 5, 6, 7, 8 factors. And that means it is also a composite number. Looking at 35. 35 has 1, 2, 3, 4. And so it is also a composite number. Then finally our 17 has 1, 2. What type of number is it? It is a prime number, simply because it has only 2 factors. Boys and girls, we are now going to have an activity to see whether what has been delivered has got to our brains. And I'm saying activity. So that is our activity. List all the factors of 6, B is 12, C is 15, D 10, 7, E 36, F 48, G 45, H 21. You are expected to list all the factors for each of the numbers that are given up to H. The number 2, how many even factors has 20? In this case, you first of all have to identify the factors of 20. And after identifying them, you get only those that are even. Remember, an even number is the number that is exactly divisible by 2. The number 3, given that set D is prime numbers less than 10, find the number of members in set D. Before you happen to tell me how many numbers are in that set, you are expected to identify what those elements in set D are. We have looked at and we know what prime numbers are, so I don't think it's going to be hard for you to get it. Otherwise, thank you. Have